All right, so I think this is recording. Let's take a look at this polynomial function. It's of degree 4. They want us to find the zeros, so there could be at most 4. We really don't have a technique like the X method that will help us in factoring these 5 terms. We do have the rational zero theorem, so it's pretty much the only tool that we have right now. We look at the constant term 8, and we look at the factors of 8, the integers that divide 8, and that's 1, 2, 4, and 8. And these are going to be numbers that we put in the numerator of a list of possible rational zeros. We look to the leading coefficient, which it's kind of nice that this leading coefficient is 1, because it just means that we have factors of positive or negative 1. That's going to be our denominator. So when you take each one of these numerators and divide it by 1, you get the same thing back. So this list of possible rational zeros. There's no guarantee that there's going to be any zeros in this list, but if it does cross the x-axis, and if it does do it at a rational number, it'll be in this list. So when we take each of these numbers and divide it by 1, we already said we get that list back again. So now it's just the repetition of the tedious task of searching all of these numbers to get a zero remainder. So 1, negative 3, 6, negative 12, 8. And I don't think this is, well, maybe. I don't know. I'm not good enough at seeing it until I get right near the end. And then, hey, yeah, it gives me a 0. All right, so we're now down from 4 degrees to 3 degrees. And we notice that we still have 1 and 8. There's when we do this, our list is never going to get longer. Sometimes it can get shorter. We've tried 1, and don't scratch it off the list yet because we don't know that 1 could be a 0 of a multiplicity greater than 1. So if it has a multiplicity of 2 or 3 or 4, then we can keep using this 1 in synthetic division. So let's see if by chance it has a multiplicity greater than 1. And it doesn't. But it was worth trying. All right. Let's try negative 1 and see what we have here. Yeah, that's not any good. Nope, and that's not 0, so we're done with 1, and negative 1 didn't work. So we can come over and try 2, see if 2 might work. Looks like it's got promise. Yeah, all right, it does work. So now we've got it down to a quadratic. So this polynomial function f of x, in factored form, we can write it x minus 1 times x minus 2. And then we need to look at this 1, 0, 4 and look at it as x squared plus 4. When we set this equal to 0, we have a zero product coefficient theorem that, well, just a zero product theorem. It says if you have a list of numbers whose product is 0, then there has to be at least 1 0 on the list. So one minus 1 would give us a 0. And 2 minus 2 would give us a 0. But x squared is only going to be 0 or positive. X squared can never equal a negative 4, not in the set of real numbers. It can with complex numbers, but not with real numbers. And that's all we're looking for right now is the real zeros. So even though this was a polynomial of degree 4, it has 2 real zeros and 2 imaginary zeros that we're just finding the real zeros. All right, well, I hope that helps, and I'll talk to you later. Bye.